Hello everyone here at the Manufacturing Summit. I am Chase DeGlopper, a systems analyst and the project manager of Leading to Lean project here at ADAC Automotive. Today I will be presenting on what it looks like to transition from paper and Excel, mostly manual-based processes, to an automated state using Leading to Lean's production module. So that being said, let's take a glance at the presentation agenda here. The first item I would like to briefly cover is ADAC's company history. And then next, I'll be moving on to, going over the multitude of different systems which were set in place prior to Leading to Lean's implementation. I will then compare and contrast the previous manual-based systems to the automated state in which ADAC is currently transitioning to. I will focus heavily on two of the three counterparts of OE in this presentation, one being scrap and the other being downtime. And then I'll also be focusing on the integration between Leading to Lean and our ERP system for automated inventory adjustments. And for those of you who are curious about timing, I'll be reviewing the implementation timeline, covering implementation dates, and the phased approach that ADAC took. Then I will display from a 30,000-foot view a series of ADAC's production systems and how they relate to Leading to Lean. And the main reason behind doing so is to display the relationships and to outline the complexity and the holistic nature of Leading to Lean manufacturing system. And the last topic is to cover the next steps, and the next steps are basically a dyad of items in which ADAC is looking forward to implement. Then afterwards, obviously, there is a Q&A in which I will be able to answer any questions that you guys may have. So the first topic, let's briefly cover some ADAC history. ADAC is a Tier 1 automotive supplier. ADAC is part of a larger group called the VAST Group, which is comprised of three different companies, including Vita, ADAC, and Stratec. ADAC specifically specializes in vehicle access systems. And vehicle access systems are really any system or mechanism which allows the entry or exit of a vehicle, such as the outside and inside door handles. Little demographics, ADAC has 1,300 employees, most of which are located in ADAC's four main production facilities in Western Michigan. And a little bit about Leading to Lean. ADAC started the implementation of Leading to Lean back in March of 2019, beginning with the CloudDispatch module, aka the maintenance module. So once the maintenance module began to mature, we then transitioned to the implementation of the production module, which began in November of 2019. The next handful of slides, I'll be reviewing the impact of the production module to date. However, the first item we're going to cover are these manual-based systems that were set in place prior to Leading to Lean's implementation. So there are a few systems that I'm displaying here. By systems, I'm simply referring actually to a piece of paper, an Excel dashboard. However, one key thing to note here is there were a few other systems that were set in place, such as a dashboard that links to ADAC's database. However, that dashboard was slow and clunky, and it really only displayed raw data, which wasn't, ironically enough, which was then in turn entered into the same Excel spreadsheet, which is located on the bottom of this presentation, which the output of that, which I'll review next slide, is simply just a graph. But let's not focus on that right now. Let's focus on the top right corner. This image depicts a simple piece of paper which an operator would fill out as the day would progress. We have hour time slots aligned on the left and reason codes aligned along the top. And this entire paper represents the amount of downtime that was recorded over a shift for a single line. So what does this process actually look like? Well, if a line were to fault, an operator would document the number of minutes an operator would document the number of minutes the line was down in the corresponding hour, and with the corresponding reason why. And as you can see in hour 2, the line went down for 5 minutes for some random label system issue, we really don't know, and also went down again for 5 minutes for some mechanical issue, and so on and so forth. So once the shift is actually complete, the operator will hand in this piece of paper to the team lead, and the team lead would then comb through that data for validity purposes and then enter that information into the Excel spreadsheet, which again is located on that bottom portion of the presentation. One more key thing to note here before I move on to the output, there is a very similar process to record on how to record parts produced, which is like production actuals, and the number of scrap parts. So once this data is entered into Excel, the output looks something like this. Again, this graph represents downtime. This specific chart and a few others like performance or scrap would be posted to Gemba boards for Gemba meetings and used by team leaders to manage their lines, their areas, etc. And one of the most important things to note here are the buckets in which the downtime is recorded in, aka the reason codes. So we have, label system, which is extremely generic. We have mechanical downtime, again, probably even more generic. Because these codes are so generic, unfortunately, using these buckets to assign downtime does not provide the level of detail needed to make smart business decisions, right? So what is the solution? Well, I already mentioned that ADAC has a database, which is a repository for loads of information. However, we didn't have that great delivery method, right? We had a dashboard, which was clunky and slow. However, let's replace that clunky dashboard and the manual-based systems with leading to lean. So what I'm displaying here is basically the most basic of client server models. And just one thing quick to note, and not every integration follows this exact structure, but it is a good beginning point to assist with describing ADAC's integration architecture. So first of all, everything begins at the programmable logic controller or PLC level. And once that PLC records some piece of information, it is then transferred to ADAC's SQL database and then populates a series of tables. So to keep things easy to follow, I highlighted 3 tables: production count, which records number of parts produced; scrap, which records the part number and the scrap reason; and then the final table, which records machine state, which is basically like downtime reason codes and the duration. Once this information is logged in the SQL tables, we can now access this data and then post them to Leading to Lean via API in real time, which we are going to review next slide. Now, this in turn allows end users to receive real-time notification and as a query method to extrapolate information by using Leading to Lean's report suite, which I'm going to transition to. So here at ADAC, we call downtime code reds. It's basically a dispatch type. What we're looking at here is one of Leading to Lean's report. It is called a time Pareto, and obviously in this case we are looking at downtime specifically. This graph is the replacement for the manual Excel-based graph I reviewed a few minutes back, and much like the other downtime report, we have minutes aligned to the left and reason codes aligned on the bottom here. That's basically where the similarity stops. As you can see that at the top of this chart, there is a drill down capability. Whether I wanted to look at a line or asset, tool or mold, etc., I can do so. However, in this specific chart, right now, I am currently looking at one machine over a week period of time and the reasons why that machine went down. With that being said, let's take a glance here and look at the reason codes. I know it's cut off there a little bit, but I highlighted one. This item here is code number 598. Its description is RTV dispense not detected, check red line unit in part for RTV. That's for 34 minutes, right? And I have another item, the last one I'm going to cover is number 596, stud 2 not sealed, fault check 181 for 10 minutes, right? So these are leaps and bounds more descriptive than the reason codes in which we previously had, right? This is gold. Team leaders would then in turn use discrete data, much like this, and other reports to discuss with technicians, report out on Gemba, and then manage their lines correctly. So in this example and in the next, it should be very easy to see the difference from our old systems to our new. So speaking of the next example, let's talk about how Leading to Lean handles scrap reporting. I know I did not display our previous state here at ADAC of how we record scrap, but it's much like the process of recording downtime, which again used pieces of paper. It was Excel-based, things like that. So what do we got here? Well, this graph is called a scrap category Pareto. It displays quantity of scrapped parts and the reason why. Again, notice that drill down capability, which I'm going to reference here in a couple minutes. Much like the automated downtime logging report in Leading to Lean, this automated scrap recording allows the end user to easily view data in real time proving to be a useful tool for managers to manage their areas, for team leads as well, which we have been using a lot here. So on to my last integration. I'm calling this an auxiliary integration because it's really an add-on to our scrap integration. This integration was a huge time saver for operations. Our main goal was to eliminate that paper-based process, and for this example, we were triple handling documents and keying in information in two systems, which is why we set it to such a high priority. We wanted to eliminate this process right away and then transition it to leading to lean. There's a piece of information that's really key here I need to describe before we really get into this chart and what it means. So in leading to lean, you can assign whether a scrap category is rework or not, which I've displayed on the top right corner. I have two scrap categories. One is improper ID label, and the other is station 8 wire loop fault. So the improper ID label is not deemed rework. As you can see, it says rework false. And what that really means, excuse me, is this part will never really be reworkable, right? It's just simply going to be thrown away. Now, for the station 8 wire loop fault, it's the exact opposite, right? This, if a part were to scrap out and have this reason why, it would be deemed reworkable. So what would actually happen for this, just a scenario, just for example, if a part were to scrap out for station 8 wire loop fault, a technician would grab that part with the wire loop fault, move that wire over, and then run it through the line to finish the assembly process. That is basically what we are seeing here in this graph. Week of 02/24, which is February 24th, there were 14 pieces of part number 4603 R6141 that were not reworkable, and 6 that were. So that alone is a handy tidbit of information to have so we can better understand how to mitigate different types of rejected parts. However, ADAC has leveraged this data to do an integration between leading to lean and our ERP system. So I'm going to bust out a laser pointer here to review the next slide. As you can see, this is a piece of assembly equipment, and then here is station 8 right here. So in this scenario, we have the part that's running is 4603 R6141. Obviously the part will fault here at station 8. Okay, so the part fault reason why is the station 8 wire loop fault, which we covered earlier. What happens after this? Because this station 8 wire loop fault has been assigned to be reworkable, the question that's asked is basically, is this category of scrap reworkable or not? Okay, well, it is reworkable, it's true. So if true, then this part is recorded as rework in leading to lean, and then is reworked by, let's say, a technician, and then assembled again. Okay, if this rework was false for the station 8 wire loop, which it is not, then the part would automatically be recorded as scrap in leading to lean and then disposed of, basically thrown away. Then an inventory adjustment is made in our ERP system automatically. So there is a separate transfer service that's basically running in the background, which allows this integration to happen between leading to lean and our ERP system. In the instance in which a part will fault and it's not reworkable, then our ERP system will basically adjust accordingly, right? If we have one part number 4603 R6141 in this example being faulted out for a reason that is not reworkable, then the ERP system will adjust by 1. So that's a pretty cool and unique integration in my opinion. Let's just jump right on into the implementation timeline, which will outline how long it took ADAC to implement some of these items. After the implementation, acclimation, and maturity of the CloudDispatch module, again, aka the maintenance module, after this was well underway, we started the implementation of the production module in early November for assembly operations in just one of our production facilities. And at this moment in time, all aspects of the production module were manual using the operator portal features. So we implemented this, the production module in a phased approach, which I highly recommend, by the way. We added new features on a weekly basis, beginning with entering production actuals. Then we moved on to logging scrap, and then downtime by using the operator fix feature. And then we finally implemented the skills matrix and user clock-in feature. So after a degree of maturity, we began to then automate those OEE components, right, which were previously manual in leading to lean, such as, again, the production actuals, downtime, and scrap. And then later on, we implemented that inventory adjustment integration, as I just covered. So all in all, the total time to set up assembly operations to automatically capture data in one of our facilities took around 4 months. However, let's review some of the complexities involved around implementation and why exactly it took us 4 months, with the next slide covering the integration scope. So first things first, I'm not going to get into much detail because we would need the entire duration of the manufacturing summit to do so. And believe it or not, this is actually the 30,000-foot view of ADAC's production systems and how they interact with each other. Right, for example, a majority of the orange nodes that you see here would demand 5 to 15 pages of supporting documentation to understand the complexity. By the way, which I also recommend doing, right? Creating a large amount of documentation covering the complexity of these integration interactions between systems really helped me out throughout this entire implementation. To begin with this diagram is called an ERAF diagram. It stands for entities, relationships, attributes, and flows. Let's look at the key here. The large orange squares are systems, such as leading to lean, located on the right side of this ERAF diagram. The lines connecting all of the entities display the flow of information between the systems, servers, applications, and the like. The green boxes interrupting the lines connecting to the entities are integrations. I'm talking about these green boxes, are integrations that have currently been implemented. And the yellow boxes interrupting the lines connecting to the entities are opportunities to integrate. And some key information here about this slide is, guys, do a business process review such as this one and get into the nitty-gritty. Then if something, just in case if something were to go wrong for whatever reason, you've already done your homework and the solution should be much easier to find, especially if you have supporting documentation. Obviously, where it makes sense, let's automate. On to our last slide. So for the last slide with actual content, let's discuss the next steps or areas for ADAC to complete next. The most important integration that is coming up on my radar within the next couple months is the capability to link our ERP system to leading to lean such that product orders will automatically populate in leading to lean and automatically appear in the eKanban planner and other screens in leading to lean's production module. Currently, ADAC is using the data load method or mass uploading orders to leading to lean via an Excel document. What this process actually looks like is a team leader would go into our ERP system, export the queued orders ready for production into an Excel document. They would save that document and then import that Excel document to leading to lean via the import feature. And all that is fine, but it's just another step that we would like to eliminate, basically to save time and eliminate any potential errors when doing the upload manually. So we're really excited for that integration to happen over the next couple months. Now the next item to set in place is, okay, first we need to finish the implementation of assembly operations. However, once that is finished, then we can get the necessary integrations up and rolling for our molding operations. Now this includes all the aspects of OEE, production actuals, scrap, and downtime, and that integration between leading to lean and our ERP system to automatically perform those inventory adjustments. And now last but not least is to complete the 9 other A3 projects I have on backlog to make leading to lean operate like a well-oiled machine. Well, guys, we covered a lot. I have this Q&A portion that's going to be up and running here in just a second. So if you guys have any questions, please feel free to ask them and I will answer them. All right, thank you guys. I appreciate it.